Alright, I'm slowly making my way through chapter 2 of Fire in California's Ecosystems, and I was pretty interested to read this next section because it goes into the North American monsoon and lightning, and then the impact that that has on wildfire. I was very interested in this lightning section because how I really started to get into wildfire in California was in 2020, and I think everybody can remember there was Tropical Storm Fausto off of the coast, and it funneled in a bunch of moisture into California. It just created hundreds of lightning fires all over the state. Some of those ended up growing into the LNU lightning complex, the CZU lightning complex, the SCU lightning complex, and I was living up in the mountains directly between the CZU and the SCU, and for about a week there was ash falling on the cabin I was staying at up in the woods up there, and that was why I really needed to know where the fires were. Were they growing towards my house? What was the wind direction? I was doing fire clearing for hours and hours every single day. I was looking up all sorts of maps. And that was actually when I started doing wildfire forecast videos, because I was already looking up all the materials to try to figure out the information for myself. And then I figured, there's probably some other people who need to know this information as well. And those were all lightning fires that started. Now, interestingly, lightning in terms of fire ignitions is somewhat rare in California. The large majority of fires that start in California are actually started by people. But when it comes to that lightning, it is interesting where it mostly occurs, when it mostly occurs, and then how that does impact wildfire. Now, before I answer those questions, we have to first understand what the North American monsoon is, because that's where the majority of lightning strikes in California come from. You can almost picture a high pressure system filled with moist, unstable air over Mexico, and that's spinning clockwise. So I think it's backwards when you guys watch the video right here. So it's spinning clockwise. So when that's over Mexico, it's really just pushing in some dry air over California from the southwest. Now, where this starts to lead to more monsoon activity and thunderstorm activity and lightning activity in California is when the jet stream shifts a little bit north up above California, and then this high starts to fill in over the Colorado Plateau or the Great Basin. And then instead of having the dry southwesterly winds, we start to have very moist, unstable air funneling in from Mexico. It's almost like tropical air, and that's often when it does feel a bit like a monsoon out there, is when you're getting some rainfall, but then it's also somewhat hot, and it almost feels kind of tropical in California. And again, this is mostly during the summer months. So that is where a lot of our thunderstorm activity comes from, but it's not distributed evenly across the state. It's going to be a lot more in your higher elevations and not so much for your coast. The main reason for that is ties back to the marine layer. I've talked a lot about that just because it's such an important feature within California climate, but it's where the land during summer is much warmer than the ocean. And then the air above the ocean is pretty cool as well. And then we have onshore winds that will blow that cool air in over our coastal cities. So you end up with this layer of cold air, or relatively cool air, close to the surface with warm air up above that. And cold air is denser than warm air, so that's what you'd call a stable atmosphere. The cold air doesn't really want to rise because it's already more dense, so it's almost like a salad dressing jar, where it starts to, if you let it sit for a while, it layers out. Think of that cold air as that bottom layer, but think of unstable air as if the less dense material was first on the bottom. It would want to rise up and get to the right levels. So that's what happens more in the inland areas where you have a lot of daytime heating. So the ground gets very hot, and then that hot air wants to rise, and then that's what leads to a lot of your thunderstorm activity. And then when you have the North American monsoon, there's also moisture in the atmosphere. So that rising air leads to thunderstorms, which leads to lightning. So now let's get into where this lightning occurs. Now, I already mentioned it's more in the higher elevations, less in the coast. But when it comes to the actual regions, this was a question that I got wrong. I would have guessed the majority of lightning strikes were up in the Sierra Nevada, but it's actually in the southeastern deserts. So from 1985 to 2000, there was about 1 million lightning strikes in California. Almost half of those were in the southeastern deserts, and most of that was from monsoon activity. Then about 200,000 of those strikes were in the Sierra Nevada, and the rarest place to get lightning in California, like per basic or per area, so talking about lightning strikes per kilometer, would be the Central Coast. And that was actually something I read in another textbook previously that said that the Central Coast has the lowest amount of lightning strikes in the entire United States per area. Now, I have to specify per area because if you're comparing a very large region against a very small region, then obviously the small region would have less lightning strikes, so you have to kind of divide it by the size of the region that you're talking about. In that regard, the North Coast also doesn't seem to have all that much lightning. And then again, big part of the reason the coast doesn't have as much lightning is because the marine layer creates stable air that leads to less thunderstorm activity. Whereas southeastern deserts, you can imagine, ground gets pretty hot, you're going to have a lot of rising motion. And then also up in the higher elevations like the Sierra Nevada, you're going to have a lot of convection. And that is something interesting about lightning fires. They often do happen in those high elevations. So you can have these lightning fires get fairly large just due to the fact that they're, for lack of better words, they're often in the wilderness, and it's in very steep terrain. It's hard to get to. So they're able to burn a lot longer before crews can get there, and maybe they also won't even be that big of a priority because they're maybe actually just helping the ecosystem instead of threatening lives and property. So that's where a lot of lightning fires will burn for quite some time, as long as they're, not threatening anybody. So that answered the where question. Most in southeastern deserts, least on the Central Coast. Most in the inland high elevation, less along your stable coastlines. So now let's talk about when this happens. For most of California, it's going to be correlated with that monsoon activity, because the more monsoon activity you have, the more lightning strikes you're going to have. And the perfect statistic that ties those together is the denser your lightning strikes, typically the more summer precipitation you have, which is a good indication that it's associated with the monsoon, because we don't get storms coming down from Alaska in the summer. That's more how we get our winter precipitation. Summer rain usually comes from the south. So when does it strike? For most of California, it's going to be July and August, but then on the Central Coast, it's August and September. And then for time of the day, I'm sure a lot of people can guess this one. If your thunderstorms are forming because of convection due to daytime heating, most of your lightning activity is going to be at the hottest time of the day, so between noon and 4 p.m. And then the smallest amount of thunderstorm activity is going to be when it's a lot cooler, so between 4 a.m. and 8 a.m. So that sums up the where and the when. Now let's talk about how this impacts wildfire. So as you know, in 2020, it led to one of the worst wildfire seasons in recent history. It burned over 4.3 million acres. But it is also interesting to know that that's a pretty rare event. Like a tropical storm usually only comes into California maybe once a decade. That was something we saw this last summer. We had Hurricane Hillary, which turned into Tropical Storm Hillary, which did bring a very large amount of rainfall into Southern California and then up into the Sierra as well. And that does have some impacts on wildfire activity because it brings a lot of moisture back in your fuels. But the normal monsoon doesn't have that big of an impact on your wildfire activity. Not in terms of rainfall, and I would say even in terms of lightning as well. The reason for that is because just because there's a lightning strike doesn't mean a massive fire is going to grow. In fact, there's kind of two limiting factors when it comes to lightning creating a fire. One is how much moisture is in the fuel. That one's pretty intuitive. The drier your fuels are, the more likely it is that a lightning strike will lead to a fire. But it is pretty rare. I didn't read it in this textbook, so I may have to double check this fact, but I remember reading that in Yosemite, out of all the lightning strikes they had, only about 5% actually led to fires. And then of the fires that do start, the majority of them are actually going to be small, because the second limiting factor is the continuity of your fuels. So how much fuel do you have? And the majority of fires, I think the best way to put this is fires follow the Pareto distribution. If you've ever seen that, it's where it's almost like a very small number of basketball players score almost all the points. A very few number of stars in the universe have almost all the mass. A few rivers have almost all the water. A few cities have almost all the people. Well, a few fires are almost all the acres burned. Or in other words, the large majority of your fires are actually going to be fairly small. And then it's a few big fires per year that make up the majority of your acres burned that you have. Perfect example is this year, where it's been a pretty good year in California in terms of wildfire. Our 5-year average is around 1 million acres burned at this point. And there are some questions as to how useful acres burned is as a metric of wildfire activity, but 5-year average is 1 million acres. This year we're around 250,000 acres, and a large majority of that is just from a few big fires. And then we've had maybe thousands of small fires that you never really hear about. So that was a decent amount of information right there, but the moral of the story is that the majority of lightning that comes into California is due to the monsoon. The majority of that lightning will be in the southeastern deserts and then in the Sierra Nevada. Smallest amount along the coast where we have very stable air due to the marine layer. And then of the lightning strikes that we have, very few of those are actually going to turn into large fires. So hopefully you learned something throughout the course of this video. I'm going to continue to make my way through this massive textbook. It's been very interesting so far. So if you want to learn more about wildfire, you can come on this journey with me, and thanks for watching.